We are from the Spatial Intelligence Research Group at Northeastern University. This demo shows an XR digital twin, or real-time detection of the environment, and instant spawning of matching objects in VR. On the local side, the operator in Quest 3 interacts with the virtual control panel. The control panel controller encodes those actions into ROS topics, which a ROS publisher exposes to the network. These messages traverse the internet and arrive on the robot side, where a ROS subscriber feeds the robot controller and executes motion locally at the Boston GNB. Telemetry is published back from the robot and consumed by a ROS subscriber and feedback controller on the VR app. This updates the digital twin and status panels in real time. We run two media paths in parallel. The first is the camera that streams a live feed from the robot to the VR app, so the operator always has a direct view. Second, inside our AI RAN block on the robot side, we pre-process frames, run object detection, and then compress frames before sending them as compressed frames to the local application. The VR app fuses these detections with the view to spawn detected objects and provide guidance. Finally, for graphics performance, we support an off-board rendering host on the local network. Using AirLink, heavy rendering can be offloaded to that host, while the Quest 3 remains as the interaction endpoint. This view places the user in a virtual industrial environment with multiple missions, the featured robot, and an interactive robot controller panel, allowing direct control of the physical robot. As soon as the user engages the controls in the robot controller panel, the selected inputs are converted into precise motor commands and sent to the robot. In parallel, the robot streams live telemetry data ranging from the joint measurement angles to secondary performance metrics back to the user's device. This data is in turn used to update the digital twin frame by frame to reflect the robot's posture and motion. The associated numerical values are then shown beside the robot controller panel as well as the corresponding motors. A fixed camera in the workspace continuously captures the robot's environment, tracking both the robot and surrounding objects in real time while computing their relative separation on a 2D plane. The live video stream is sent to a dedicated detection server where object detection runs on the incoming frames. In parallel, the system calculates the distance from the robot to each detected object and decomposes it into X and Y axis components. These per frame X and Y distances are then transmitted to the user's device, which uses them to place a corresponding virtual object at the exact measured offset from the robot within the digital twin scene. This ensures that the virtual environment not only replicates the robot's posture and motion, but also the objects surrounding the robot with respect to it.